Hello folks, hopefully you are doing well today. I would like for you to try the warm-up. If you can do number 1, fantastic. If you remember how to complete the square. Number 2, same thing. If you can remember it, then great. If you do not remember it, then here is a little intro. Start by subtracting or adding the 7 to both sides. Then, to solve by completing the square, we add b over 2 squared to both sides. Now, this is a, that's b, and then the negative 7 was c. So, if I take 6 and I divide it by 2, and I square it, I get 9. So I add 9 to both sides. That gives you x squared plus 6x plus 9 equals 16. But then, completing the square literally means turn it into a perfect square. So, factor that. Yes. You end up with 4 plus 3 squared, x plus 3 squared equals 16. Square root both sides. You get plus or minus 4. So if you need to separate them, because some people have a hard time with this, so if you want to do x plus 3 equals 4, and then x plus 3 equals negative 4, that's a little easier to figure out that you get 2 answers. So hence why you get 1 and negative 7. Now, the other one, my hint to you is be careful, because you have to, yes, add the 2 to both sides, but then factor out a 5 first before you complete the square. Take a second, pause the video, see if you can get it. If you can't, no worries, I'll go through it in a sec. Alright, if you got the right answer, awesome. I'll go through it though so you can see for sure if you got it. If you ended up getting 2/5 plus or minus radical 14 over 5, more power to you. But what you have to be careful of is factoring out the 5 first. Okay, so you end up with x squared minus 4/5 x equals 2. Okay, then you have to add half of this squared. Half of that simplifies to 2 over 5, because if you take half of 4, it's 2, and then you're still dividing by 5. And then you square it, and you get 4/25. Okay, because you can square each term. Hence why we're adding 4/25 here, and we're adding it here. The thing you have to be careful of is when you add the 4/25 to the right, we had factored out a 5, meaning we divided out 5. So we have to multiply it back through. So you end up adding 4/5 times 5, which simplifies to 4/5. From there, you can simplify a little bit. You end up with 14/5 if you add those 2 fractions. Common denominator. Then, you can divide both sides by 5. So you end up with 14 over 25. Now you can square root. Square root of 25 is 5. And then you still have the square root of 14. You can add the 2/5 to both sides. And voila, 2/5 plus or minus radical 14 over 5. Alright, so why are we doing this? You will see in a second if you flip it to the next question. Alright, so you guys already saw the video that was in here on how to actually see what a conic section is. That was your homework the other night. So what I'm going to talk about here is if you take a cone and you cut it. And I'll give you a nice visual next time we see each other too, but if you cut it horizontally, hopefully you'll see you get a circle, because when you open it up, it ends up being a circle. If you cut it sideways, elliptical. If you cut it, but it only cuts through part of it, parabola. And if you cut it vertically and it goes through both, it's a hyperbola. Now, parabolas and hyperbolas can be sideways or vertical, so that's why parabolas are actually kind of new to us right now. The circle part is going to be the nice thing, because we've seen that a little bit. Now, the things that don't come out to nice figures are called degenerate conics, meaning if you go through the middle, you get a point. If you go all the way along the side, you get a line, and then if you go through both sides, you get 2 intersecting lines. Weird. Okay, next, what you can look at is the definition of a circle. So just a reminder of the definition of a circle. It's a set of all points that are equidistant from a center point. Okay, so the distance is the radius, obviously. The new thing for us, which you saw in geometry technically, was standard form, where h comma k is your center. So then from there, you can plug in your radius, and that would give you your r value, and then you have to just square it. Okay. So next up, we have finding the standard equation of a circle. Now, if they give you a point on your circle, and they give you the center, just a reminder that the center is your h and k. You could technically just like count here to figure out your radius. Or a really nice way to do this is recognize that this is like your x and y. So you could do 1 minus h, which is -2, square it, plus y, which is 4, minus -3, square it. And that gives you r squared. So that can give you your radius very easily. So that ends up giving you 3 squared, which is 9, plus 7 squared, which is 49, equals r squared. So you end up with r equals the square root of 58. From there, then you would be able to just plug it back into the standard form of an equation. Now you don't have to reduce that radical, because what happens when you plug back in is you end up with x minus h, which is going to be -2, so plus 2 squared, plus y minus k, so y plus 3 squared, equals r squared. So think about what happens to your radical in your 58. It goes away, okay, because this is r squared. All right, next up we have sketching a circle. Woo! Okay, so sketch the circle given by blah, 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 identified center and radius. Okay, so the thing you want to do when you're given this form is you want to complete the square. The thing you have to be careful of here is that you're going to complete the square twice. So what I like to do is group our variables together. So you want to put it in standard form so that you can find the center and radius very quickly. Okay, so I'm going to group my x's together. I'm going to say it's x squared minus 6x, and then plus y squared minus 2y, and then I'm going to equal that to -6. So I just moved that over. I have to complete the square for both of my variables. So my first one is -6 over 2, because remember you add b over 2 squared. So -6 over 2 squared is, you're going to add 9, but you got to add it to both sides. For the y value, if you take -2 divided by 2, it's -1 squared is 1. So you're adding 1 to both sides again. So now you end up getting, once you factor, your standard form. Okay, so you end up with 10 minus 6, which is 4 for your radius squared, and this is x minus 3. Just remember you're factoring these. Okay, so my center ends up being 3, 1, so just be careful, it's the opposite signs here. Your r squared equals 4, which means your radius is dose. Beautiful. So what we do is we plot our center, so 3, 1, boop. And then you can graph your radius by literally going out 2 in all directions. So 2, 2, that was a little off, but 2, and then 2, and then do your best job of drawing what looks like a circle. Hopefully yours is better than mine. Oh, I should use the shapes. Did I get a circle shape? Nope, no circle shape. All right, folks. The next part is going to be figuring out your x and y intercepts of your graph for a circle. So think about how you actually find an x and or y intercept. What would you plug in to your x values to find your y-intercept? So that if you figure out any y-intercept, what do you plug into x? That is correct, you plug in 0. Okay, so if I plug in 0 for x, I figure out my y-intercept. Okay, so let's do that one first. So we get 0 minus 4 squared plus y minus 2 squared equals 16. All right, then from there, we get 4 squared, which is 16, equals y minus 2 squared plus 16. All right, sorry, I did that a little out of order. But what you end up with is when you subtract the 16, you get 0 equals y minus 2, and that squared should be on the outside. Whoopsie. Okay, From there, don't FOIL that, because you can just square root both sides. So you end up with only one answer of y minus 2 equals 0, because the square root gets rid of the squared. So your y-intercept is 2. And I would ask you to write that as 0, 2. That's your y-intercept. All right, x-intercept I would like for you to try on your own. Think about what you're plugging in for y at this point. Pause the video, come back, you'll have an answer. All right, folks, if you got 4 plus or minus 2 radical 3 for your x-intercepts, fantastic. Proper form would be 4 plus 2 radical 3, 0, and 4 minus 2 radical 3, 0. Okay. If you did not get that, follow your process of x minus 4 squared plus 0 minus 2 squared equals 16. Subtract the 4 to both sides. You get 12, but that simplifies a little bit to 2 radical 3, because remember this is like radical 4 times radical 3. Add the 4 to both sides, you get 4 plus or minus radical 12, or 4 plus or minus 2 radical 3. All right, next up. Okay, at this point, I want you to take just a sec. Try to think about the fact that when we cut the cone, when we cut a cone horizontal, we got a circle. If you cut a cone, hence why we're calling these conic sections, if you cut it diagonally, you end up with a parabola. So as long as it's a cone that you cut diagonally, you're going to end up with a parabola. So we're used to the normal parabola that looks like this. The thing we don't necessarily know about is that when you cut a cone, it has a center, right? That center is called your focus. Now, the vertex happens at the end point of where you cut your cone, okay? So if you have something that looks like that, you've got a cone, you cut it diagonally, right? That shape that you end up with is going to be a parabola, and if you can picture that, and if you open it up, the center of your cone ends up being called a focus. So we don't want to call it a center because it's not a circle. And then where you cut your parabola, if you were to open it up, is called your vertex. And then it curves around. So imagine it looking kind of like that when you open it up, okay? What's nice is that there's also a tether point, something called a directrix. It's kind of like your axis of symmetry, but horizontal, okay? The nice thing about your directrix is it's equidistant to every point along your parabola that your focus is, okay? So notice if I graph any point along my parabola, it's equidistant from my directrix to my focus, okay? And they always create 90-degree angles across your directrix. Now, there's a lot of different formulas that eventually I'm going to have you add to your formula sheet. If you want to add it now, fantastic, or you can wait. But the formula for a horizontal parabola, what this means is it would be opening horizontally. So it looks more like that. So what happens is your focus ends up being on the inside, so this is where your focus is. That's still your vertex, so it's like the base of your parabola, and then your directrix would now be vertical. Your axis of symmetry, which we're used to being vertical, is now horizontal. Your axis of symmetry goes straight through your focus and your directrix, okay? Something else that you guys are gonna see is that the distance between your focus and your vertex is P. A lot of textbooks use P. We're going to use A instead. So we're going to actually use the A value, which is how far across your values are going to be in your parabola. And I'm going to show you what that looks like when we do some examples together. We're used to a vertically opening parabola. Your focus is literally H, whatever your H value is for your vertex. Okay, because your vertex is H comma K. All right. And then you have to take K, add 1 over 4A. Again, I'm going to show you how to find A in a little bit. The other thing that you're going to see is something called a latus rectum. Okay? I know it's a weird word. Get the giggles out. But your latus rectum is across your vertex. Okay? It goes or across your parabola. It goes through your focus, okay? So you'd go right through your focus, hit to the other side. That whole distance would be your latus rectum, okay? Same thing if it was a vertically opening parabola. If this is your focus, that is your latus rectum, okay? Those are some pieces of what you should see. Okay, so finding the standard equation of a parabola. So what we want to do is, first of all, sketch a little diagram. That's going to be the easiest way for you to figure out what these look like. So it says find the standard form of the equation of the parabola with the vertex at the origin. This is key. And your focus is at 0, 4. So let's sketch a little picture. Again, easiest way to do this. So our vertex is at 0, 0. Our focus is at 0, 4. What that tells me automatically is that it is a vertical opening parabola because my focus is above my vertex. If it was below, it would still be a vertically opening, it would just be down. If it was left or right, it would be a horizontally opening parabola, okay? So from this, what I'm going to do is use this information to figure out pieces of my equation. If my vertex is at the origin, that means h and k are both 0. Okay, so the other thing I would be able to figure out is my focus equation helps us with other parts of our equation. So I already know my parabola is vertically opening. So that means my equation is going to be y equals a times x minus h squared plus k. And I know h and k already. So the only thing I'm missing at this point is a. To figure out a, what's cool is I can actually use my formula for my focus that I have. Okay, so I want you to flip back over and see if you can see what the equation for your focus is for a vertically opening parabola and write it down. Okay, so hopefully you got that your focus for a vertically opening parabola is going to be h, comma, k plus 1 over 4a. Okay, so again, a is how spread out your graph is, basically. So if you have your latus rectum, it's the distance of 2 of those a's, basically, okay? So the easiest thing to do, I already know h is 0 because of here. So h is still 0 if you see it in our focus. It has the same x value, so of course it's going to be the same thing as h. However, now I can say that k plus 1 over 4a equals some number. Notice it's in the same spot as the 4, so it equals 4. K I said was 0, so I can plug that in. Now I can solve for a. So from there, I can say, oh, the 0 goes away. So it says 1 over 4a equals 4. And I know this is very new to us, so it's a little weird because we're used to just plugging in our center or a vertex in this case, and then figuring out a from another point. Technically that does work, but the problem is your focus is not a point on your actual parabola. So that's why you have to do it this way. So if I cross multiply, I end up with 16a equals 1. So a equals 1/16. So from that point, now I can just plug in the information I know. So my equation for my parabola is going to be y equals 1/16 x minus 0, because that's h, squared plus 0. So really it's just 1/16 x squared is your equation of your parabola. Okay, so the next thing that we're going to do is find our focus for our parabola, and we're going to find the directrix and length of our latus rectum. Okay, so the best thing to do with this equation is put it in standard form first. So what I'm going to do is actually complete the square in order to do that. So I would like for you right now, because then it'll be easier for you to find a, h, and k. I also know that this is going to be a vertically opening parabola because it starts with y equals. If it started with x equals, it would be a horizontally opening parabola, okay? So I want you to take a second and complete the square for this, and then see if you can figure out what a equals, what h equals, and what k equals based off of that. So pause the video, see if you can grab it. Okay, so actually the easiest thing to do here is to get rid of that weird fraction first before you actually complete the square. So what I would do is I'm going to move everything over so it'll be a little easier to complete the square. So I'm going to multiply both sides by -2, and then it will be faster. So I'm going to multiply both sides by -2. If I multiply this side by -2, I get x squared plus 2x minus 1. So it's a lot easier to complete the square now. You also can add the 1 to both sides if that's easier for you to complete the square. You'll just have to move it back. Okay, so some of you might find this way a little bit easier to complete the square. So now if I add b over 2 squared to both sides, I'm adding 1 to both sides. I'm just going to have to be careful to move it back over afterwards. Okay, so now from there I can factor this. I get x plus 1 squared. I already have most of my equation done. Then I would just subtract the 2. Okay, subtract 2 from here as well, and then I would divide by -2. So be careful because it's almost like there's a 1 in front of that x plus 1 squared here, and you have to divide both the 1 and the -2 by the -2 here. Okay, so you can't divide a -2 into the x plus 1 squared because it's being squared. So you end up with y equals -1/2 x plus 1 squared plus 1, okay? So your h, just be careful because it's the opposite sign of what's in here. So it's h comma k is at face value. So this is something that's a little different for us, but if you saw vertex form of a parabola last year, it should be fairly easy for you. So our h is going to be -1 and our k is +1, okay? Because this is opposite of h and then this is just k. Then our a value is -1/2. So from there, if I wanted to figure out my focus, now I just plug those values into my formula, okay? So my formula for my focus for a vertically opening parabola is, and you can just say f for focus, is h comma k plus 1 over 4a. Okay, so our h is -1, our k was 1, our a was -1/2. Simplify what's under that fraction first, for sure. So you get -1, comma, 1 plus 4 times -1/2 is -2. So this is really like plus -1/2. So your focus ends up being -1, comma, 1/2. Then they also want you to find the directrix and the length of your lattice rectum. So your formula for your directrix is going to be y equals k minus 1 over 4a. Okay, so that was in your beginning of your notes. Again, it's going to be a horizontal line because it's perpendicular to your axis of symmetry. If I asked you for your axis of symmetry, hopefully you would know it's just going to be x equals -1 because that is what your x value of your vertex is. Remember, it goes through your vertex, and if your vertex is -1, 1, that's what this means, then your axis of symmetry would just be the x value. But in this case, your directrix is the y value that's perpendicular. So y equals k minus 1 over 4a. We already did 1 over 4a in this part of the problem, so it's just -1/2. So in this case, it's y minus -1/2, which is really y equals 3 over 2 or 1.5, okay? And then the last thing is the length of your lattice rectum. So basically from 2 points going through your focus, what is that length? And that's a really key thing to have. Just be careful, it's a distance, so that's why they do your lattice rectum is 1 over a, and then you take the absolute value of that. Our a value in this case is negative, so just make it positive in your final answer. And if I do 1 over 1/2, it ends up being 2. So that means from point to point through my focus, if I were to want to, like if I wanted to graph my parabola, I would be able to know that where my vertex is, where my focus is. I'm not graphing the same graph that we have right now, but I know that basically if my lattice rectum is 2, each of these would be 1, okay? I didn't graph this parabola, but if you wanted to, that's how you would do it. All right, next up, we got standard form of an equation of a parabola with a vertex at 1, 0 and focus at 2, 0. Okay, so now we're finding the standard form of the equation of a parabola given 2 points. We have our vertex and we have our focus. So again, easiest thing for you to do to figure out whether this is vertically opening or horizontally opening is to graph it. So just do a little sketch. So our vertex is at 1, 0 and our focus is at 2, 0. So again, the focus should be inside of the parabola. So it is horizontally opening. So if your focus is to the right or to the left of your vertex, you know it's going to be horizontal, which means our equation is going to be x equals, because it's horizontal, x equals a times y minus k squared plus h. Okay, and you don't really need that first parentheses, sorry. Okay, the thing you have to be careful of is your vertex is still h, k, but notice that because it's horizontally opening, the h and the k flip-flopped. So already we know that our equation is going to start with x equals a times y minus 0 squared plus 1. So just be careful that they flip-flop in your horizontal equation because it's literally flip-flopped, okay? Your focus equation for this is going to be h plus 1 over 4a, comma k. So again, notice that flip-flopped, okay? So the formula is switched around. And then if we know that h is 1 and k is 0, now we can solve for a, okay? So we're finding the standard form. We have all the values we need except for a, okay? So what I would set up is that if you know your focus is 2, 0, I know that this equals 2. I know that h is 1 from looking at my vertex, okay? So if I'm doing that, what I can do is actually plug in my h value of 1. I can plug in the fact that I have this equals 2, and now I can solve for a. So take a sec, see if you can get it. Okay, if you got 1/4, more power to you. So hopefully you got there. From that point, then you end up plugging it in, and you get x equals 1/4. Y minus 0 is just y squared. You can leave it without the parentheses if you want. Plus 1. And there is your equation of your horizontally opening parabola. So last part of this before we do a little bit more practice is seeing where these actually show up in real life. You guys see circles all the time. You know how that's applicable to life. But there are actually a lot of examples of where parabolas show up in real life besides just like bridges and the McDonald's sign. Light. So something you should notice is that light refracts in a way that it mimics a parabola. So your focus ends up being a light bulb, and then the light source goes around the actual light bulb. So if you turn on a light bulb and you focus it somewhere, the shape ends up being a parabola, which is kind of crazy. Your directrix is invisible, and so is your axis of symmetry, but they're also present in that scenario. The other thing you can do is figure out tangent lines to that. So it would be like if you wanted to tether the light to something, you could see what would hold on the side. So we're going to do one tangent line question. It's going to be rare that it shows up as a question on any kind of assessment, but it's really good to help you figure out some pieces of information on that. Okay, so we're going to try that a little bit together right now. All right, so I want to show you where they got the information up from this. They give you P. Now, P is not something that we tend to find, but instead, if they're giving you a tangent line, you can sketch it, okay? So they said it's a tangent line of a parabola of y equals x squared, so that means h and k are both 0, at the point 1, 1. So what's nice is this is like your x and your y value. So you could use that to find an equation of a line between those points. The other thing that you can do is figure out the fact that the distance between your focus and that point is the same as your directrix in that point. So what they're saying is you could set up the fact that the distance is about the same between both of those. You could set up a triangle from there, figure out what the B value of your line is going to be, aka your directrix equation. Okay, so they're saying you could find out what B is because it's equidistant from both of those. And then you could, from there, use the fact that you now have another point on your tangent line, find the slope. You already have your B value, so you can just plug it in to find the equation of the tangent line. We're going to do a little bit more practice with this later, but for now I'd rather you just practice a little bit of your circles and your parabolas. So for this question, I want you to, or for these questions, I want you to try these on your own right now, and then next class I will give you the answers to all of them. I would like for you to try all of them though, because the first few are circles, so notice which ones are circles. Really, those are circles. And then the bottom three are on parabolas. So try each of them for me, please. Again, we'll go over any questions you have next class, and have a great day.